In the first part of the video, we already covered different components of transformers, including the self-attention behavior. We went one by one discussing the intuition behind those components. On the end note, we started discussing the definition of prompt engineering. So let us continue from that point in this video. In the first part of the video, we have already started discussing about prompt engineering. But just to maintain the flow, I'll start it from the beginning here. Alright? So consider at this point of time, you have a pre-trained LLM model that is trained on a training dataset. Now you want it to predict some of the outcomes for a specific task that you want. For that, you provide some of the inputs to the LLM models, but somehow it doesn't give you the outcomes that you wanted to see. That is, the model is not performing in a good way. So for that, what you can do is you can revise the language in the input or in the prompt such that it's written several times to get the model to behave in the way that you want it to be. Now this work to develop and improve the prompt is known as prompt engineering. Okay, before moving on, I would like to introduce some of the common terminologies which is used in prompt engineering. So the text that you see on the left hand side is the input text which is provided to the LLM model. This input text is also called prompt, while the output text which is predicted by the LLM model is called completion. Now, the full amount of text or the window that is available to us for use for the prompt is called context window. With regards to this context window, we have a limitation on the amount of words that we can use in the context window. And this limitation varies for different models. So for instance, for GPT 3.5, this limitation is at 4096 tokens or somewhere around 4000 words. So we can't use 4096 tokens in the input window. Now just to clarify, the number of tokens is not equal to the number of words. So let's take this sentence. You miss 100% of the shots that you don't take. This sentence contains 9 words, but according to the GPT model, it contains 12 tokens in it. Now if you see down below, you can see the colors that is being provided to each token in the whole sentence. And you could observe that some of the words like don't are again subdivided into different tokens. So it depends on the model how it divides the words into tokens and converts them into token IDs. So now we have some idea about the terminologies which is used in prompt engineering. Now consider this example. In this example, the output provided by the LLM model is mostly correct, but sometimes it may happen that the output provided does not meet the expectations at all. Now in those cases, we have to revise the language which is used in the context window using different techniques of prompt engineering. Now for this, there are several techniques available, but one of the most powerful strategies is in-context learning. Now in this technique, when you provide the input in the context window, you also provide the example answers or some hints or some instructions so that the LLM model could understand what it needs to predict in the output. And based on the amount of information that you provide in the context window, there are different techniques that you can adopt. The first technique is called zero-shot inference. In this technique, you don't provide any example answers, but you provide or give some hint in the context window as to what you are expecting from the LLM model to predict it for you. So like in this case, I have already provided a sentence, my name is Optimus Prime. And in that, I've also provided some of the hints that I want an answer to the statement, and I also left some of the space for the answer below. Now in this case, when the model gets an idea, okay, it has to answer on this statement, it knows that, okay, I have to start with the word hello, but it still doesn't know what to write after that. So it may happen the zero-shot inference doesn't work for the LLM model. So you go one step further for one-shot inference. When I say one shot, it means that I am providing one example answer in the context window. So for this case, if you see on the left hand side, I have already provided an answer how to greet the person who is providing his name in the input. Then I provide another statement which is I am from Japan and allow the model to predict outcome based on this input. Now it is performing a little bit better, but still it is not up to the expectations. So you go one step further and instead of doing one shot, you do few shot inference. Now in this you can do two or more than two examples provided in the context window. Now based on this, it may happen that the LLM model is able to provide the correct answer that you want it to see. But still there are cases where it may not predict the correct output. Remember, we have a limit on our context window as to how many examples that we can provide to the LLM model, since we have a limitation on the number of tokens in the context window. So the general rule of thumb is, if the model doesn't perform well even after providing 5 or 6 examples in the context window, then we can move on and do further tuning on the model instead of going for prompt engineering. Now this tuning could be training your LLM model on a specific dataset so that the model performs well on your specific tasks. Now, how do we actually know which type of models would be suitable for zero shot, one shot or few shot inference? So the general intuition is, if you have a LLM model which is trained on a huge dataset, that is, it has already learned things from the internet, then it doesn't need much of the hints in order to predict the outcome. But if you have a model that is trained on a smaller dataset, then you have to go one step further because it could not have much information to predict the output. However, if your model is trained on very few dataset, then it may be the case that even after providing few examples, it may not be able to predict the correct outcomes. So, the amount of examples that you need to provide in the context window is inversely proportional to the size of the LLM model or the size of the training dataset on which it is trained. Great. So at this point of time, we are familiar with the in-context learning technique from prompt engineering. However, there are also other techniques available which you can explore on yourself. For instance, you may try to express the query as clearly as possible. By that I mean, you must provide the specific information that you want to know from the model and avoid using vague fillers. For example, consider the sentence. Write an outline that includes a title and next steps. Now this sentence as a query is not that clear when I compare it to the next sentence which says write an outline for an academic research proposal that includes sections for title, summary and next steps. I hope you get the idea, right? The other technique is experimentation. So this is more from an open-ended perspective that you can try doing different things to see what all different kind of queries can affect your outcomes. For example, you can try using bullet points in your query, or you can try changing the tone of your query to maybe a formal tone or an informal tone and see how your model reacts to these queries. Now, as these LLM models are free to use for us, I would like you to explore these experimentation techniques or different techniques in prompt engineering to see how it affects the output of the LLM model. So that was all on large language models, and I really appreciate if you have made it till the end of the video. If you want to learn about more such topics in machine learning, then do hit that subscribe button because I'll be coming out with more such topics in future. Also, if you want me to cover topics of your choice, then do write them in the comment sections below. Thank you for watching.